Welcome to RoboBoat 2022, Day at the Carnival. I am your ringleader, Bill Porter, and we are in bright and sunny Sarasota, Florida, watching autonomous robots from around the world compete against various carnival-themed tasks, starting with Road to the Show. Here, the team's robot will need to navigate through 2 sets of channels autonomously. Next is navigate the crowds. Here, teams need to navigate through 10 sets of gates while avoiding the yellow buoys, which are the obstacles. Here is find a seat at the show. Teams have been assigned a color, and their robot will need to find that bay, correctly colored, and enter the bay. Next up is skee ball. Here, the robot will need to deliver 3 balls into the buckets for maximum points. And finally, it's water blast. Here, teams will need to fill up the water column with water and lift the red ball up to the green line. Next up is snack run, where teams will demonstrate their vehicle's ability for speed and maneuvering. They'll have to go in through the gate, around the blue buoy, and back through the gate as fast as possible. Points go to the fastest boat. And then finally, the team's vehicle returned back through the black gates, which in this task called Return to Home. They will get points for completing all the tasks, plus a time bonus for how long it took to complete the obstacle course. Due to forecasted weather, we've decided to run finals in 3 different rounds. The first round will be today at 3:30 Eastern. The next rounds will be on Saturday. In each round, teams will be given a 20-minute time slot. The last run in the time slot is the one that counts. And finally, the best team with the best round is the one who takes home the trophy.
Sunny Sarasota. Run already is ITSN. Zulieta, welcome Zulieta.
Thank you. My name is Julieta from ITS.
So this team has been on an app so far this week.
Yes.
Really showing everyone how this course should be done.
I don't have you.
Oh, what?
You're not on. You're pressing hold. Oh, so there you go.
I don't
You're
even
good.
see
You're
it.
good.
Okay. Should I start again?
Yeah, go ahead, start.
Welcome to RoboBoat 2022 here in sunny Sarasota, Florida. Currently on the course in their first finals run is ITSN, who've come here all the way from Indonesia. And joining me here on the commentary task is Zulieta. Welcome, Zulieta.
Thank you. Hello, everyone.
So your team has been doing an amazingly impressive effort all week. You've been just showing how all the elements on this course should be done. Are you happy with the performance you've done so far?
For observe.
And have you changed anything? Round. Is anything different on the boat?
No, there's nothing difference.
So we should be seeing it go through its paces and do everything. You've managed to do every task so far.
Yes.
And we're currently in autonomous mode and the docking task. And the color of the day today is green. So that looked to me like a successful dock. How long did it take you to get here from Indonesia? It's a long trip.
Yes, for around 33 hours. We're using connecting flight in Dubai.
That is a long journey, but everything seems to have gone pretty smoothly. And any breakages, any kind of last minute problems, or did everything just get through okay?
No.
Indonesian guys.
Yes.
I'm sorry, are you talking?
Yes. Yeah, sometimes on a long journey like that, things don't arrive or things get broken. But was everything okay when you got here?
I think everything is okay.
So this task right now is the speed challenge. We're calling it gather snacks in the carnival theme, and so this is a timed challenge. Boat enters through those things through the red and green buoy, circles the blue one, and returns. And then coming up next is a sort of like a carnival game to squirt water and fill the next target. How does the boat stay in the right place to direct the water on the target for this challenge?
Okay. From the the design of the ASV. We're using catamaran design, which has good stability. So there is a lot of hull design, but we choose catamaran design one because it has a good stability. So when the wave hits the ship, it good for the stability.
And how does the boat know when it's in the correct place for this particular task? What sensors is it using?
We are using camera.
So using the camera on that big blue and white mark. I noticed earlier when I came and looked at the boat that the thrusters are able to turn sideways. Do you turn them sideways to stay in place on this task, or do you keep them pointed forwards? And we know when this task is done because there's a little orange ball that floats up to the top when it's filled with enough water. How does the boat know? Does the boat check that, or does the boat just do it for a certain amount of time?
We have a roulette mechanism. We're using 3 of balls. When the first ball is the short one, and then we wait 4 seconds to launch next balls.
But for the water task, how does the boat know when it's finished? Does it see when it's completed the task, or does it just squirt for a certain amount of time and then move on? Yeah. So now approaching the ski ball task, we're calling it. Yep. And you'll have 3 shots at that. See, I notice here the boat is kind of moving sideways. So is that where you have turned the thrusters to point sideways?
Yes. We have 3 thrusters, and the 2 thrusters in the back of the ASV, and the 1 thruster in the front of the ASV.
Perfect. First shot into the bucket. For this task, is the camera looking for the buckets? Second shot in the bucket. Excellent shot. Three in the bucket.
Nice.
Congratulations. That is the best ski ball shot that I've seen this whole week. And now heading to the final element, which is the return to home. So in this final sequence, the rules are that we keep the score from the last run. So how do you think that run went? Do you think you'll try again, or do you keep that one? All right, so the first run, a great run, and that is going to be kept. So when did you start working on the boat itself? When did you start construction and design of the boat?
Okay, basically we're joined this competition in 2019, and the design is also catamaran but a different dimension, and we learn from that design, and we redesign with much of difference, the dimension and the system, also the system, I guess.
And so from 2019 to now, this is 3 years, how many people are on the team now who worked on the team back in 2019, and how many are new?
23 students, undergraduate students.
But how many of those 23 were working on it in 2019, and how many are new people?
Basically, we have three divisions in this team. The first one is EPR. EPR is Electrical and Programming Division. The second one is Mechanical Divisions that design the ships and build the ships. And the last one is Non-Technical Division. And the last one, Non-Technical Division. And Non-Technical Division is the division that work at sponsorships, marketing, and social media branding.
And between 2019 and now, there weren't any other competitions because of COVID. So I heard that you did a lot of simulation during that time. Are you able to tell us a little bit about what you did before the boat was built? How did you practice?
Actually, every year we join national competition in Indonesia. There is KKCTBM.
A good chance to practice.
Okay.
Because for a lot of teams, I think they didn't have any chance at all to practice. So it's good that you got to actually. So, but did you use the boat from 2019 or this boat?
No, this new boat.
Okay. And so this one was created. Early, this year.
Sorry.
When did you start to build this one?
Around January 2022.
Okay, so it's really new. So, do you think you will take this boat to some of the Indonesian competitions? Are there more this year in Indonesia?
No. This is special for RoboBoat.
Okay. And do you think you will use it again? Will you come again next year and use it again next year, or build a new boat?
Maybe, but we're thinking about joining RoboX competition.
That would be very exciting.
Yes.
RoboX, much bigger boat, a 5-meter catamaran. So.
It's a big boat.
But I think a lot of the software systems should be able to transfer over. The tasks are quite similar.
And this year we're also joining the online robot X competition, but just for the first step.
And how did the team perform in that? Did you have success in that competition?
No, actually no. We're just trying.
But so that competition being virtual, it's just a simulator. Do you feel like for your software team, was that simulated environment useful to you in preparing for this competition?
Simulation, and also we try in environmental.
Yeah, how is the environmental conditions here different from what you're used to at home?
The lighting and wind, and also the waves.
Yeah. When you practice at home, what sort of water do you practice on? Is it outside in a pond, or is it in a swimming pool?
In a lake, but smaller.
And what about the lighting is different here? Is it much sunnier here?
Yes, sunnier here, and this is so hot.
Yeah, even. For a camera, the difference between a very cloudy part of the day and a very sunny part can be very, very different, right?
So different.
And so you are the social media and branding team, and are you also responsible for fundraising?
Yes.
Tell me about that. How tough is it to raise the money for? Because the equipment is expensive, and bringing a team all the way to the United States is very expensive. So tell me a little bit about what you've done for fundraising.
In the beginning of 2022, I think we can able to join this competition because at that time we didn't cooperate with any sponsors. Around February 2022, me and my friends starting to search cooperate to gain the sponsors from them, and we can join this competition supported by sponsors.
Would you like to thank any of those sponsors?
First, we're so very thankful to Telkom Indonesia, PLN Indonesia, BKI Indonesia, Petrokemia Gersik, and PT Algas Indonesia that supporting us to join this competition and doing our research on the ISV.
And what's the support like from your university? Is this something that the university knows about and is supportive of?
Yes, in my university has a club, robotic clubs, and in the robotic clubs there is a lot of teams. The one is Baruna ITS that work in ISV. So in the robotics clubs, we can use any tools in there, and also we facilitate to trial in the lake in our university.
And how big is the university? How many students are in the whole university, and how many in the robotics clubs? Roughly.
So much students in there.
It's like 5,000, 10,000. You know.
Maybe.
Wow. Okay, that's a big university. And how many of those are interested in the robot clubs?
Sorry?
How many students are part of the whole group of robot clubs?
Actually, there's a lot of students that interested in the robotics clubs, but we're using mechanism that we have to eliminate students that want to join these teams.
So there's more people who want to join than
Yes.
can be on the teams. That's a good situation to be in. What attracted you to participate in robotics?
Sorry?
What made you want to join the robotics team personally?
Basically, because my department is from naval architecture, so I want to join Barunasar ITS when I joined this university. So yeah, I think in line with my department and my major.
And what year are you in now as an undergrad? What year of college?
Sorry?
What year are you in your?
I'm in third year.
Third year.
Yes.
And is it a 4-year degree, naval architecture?
Yes.
So you think you'll return on the team next year if you come again to RoboBoat or to RobotX? You'll stay doing it? A lot of work?
Yes.
Well, we're seeing the next team start to get set up here. I'm not sure where we are on the time clock. Okay, so thank you very much for joining us, Julieta. Congratulations on a fantastic run. We really appreciate it, and I'll let you go and celebrate with the team now. Thank you.
Wish us luck.
Yes, good luck.
To me now. I'm gonna make it work.
All right, so that was a fantastic run from ITSN. We've just seen them perform amazingly out here on the course all week, and to see a team just show up with that kind of confidence, run the course once, and say we're done, that's a pretty unique thing for RoboBoat. I'm joined up here now with Bill Porter, the technical director of RoboBoat. Welcome, Bill.
Oh, thank you. Thank you, Zaz. I definitely agree. Yes, no, we're having microphone issues. Forgive us. Yes, it is great to be back after such a long break. I was also as thrilled to see a team absolutely roll the course. It's it kind of makes it feel good that these tasks are achievable, if some level of difficulty. So it was definitely awesome to see that team jump on the course and really do a stellar job going against all the tasks. And it really makes me wonder what kind of preparation work they did to be so ready to be here. Because I'd love to see more teams sort of in that ready to go stance.
Yeah, I was really surprised when I talked to them earlier, and they told me that they had only built the platform earlier this year. I mean, still, that's half a year worth of preparation, but it sort of felt to me like they'd been practicing for the last 2 COVID years with this boat, because they just had performed so well. So that they got everything spun up and working with that level of reliability in a relatively short amount of time, I thought was really very commendable, because a lot of times in these competitions, because the environmental conditions are so unpredictable, because the tasks are challenging, consistency is often lacking. And especially on some of the more difficult tasks, the fact that this team was so consistent, I thought, was really stellar. What do you think about that, Bill?
I think you nailed it. You hit the nail on the head. This is a real world environment, and a lot of what we see the team struggle with year after year is not accounting for wind changes, swells in the water, things like that. I think when we see a performance like that, what we saw is a team that has been testing. Testing is definitely the key. Getting on the water and learning those lessons before they get on site is what makes it stand out. We see the teams learn the lessons here, and I'm glad they learned the lessons here, but it's usually at a detriment at final performance. So that was clearly a team that had been on the water for a while before getting here. Even if it's a new platform, it's just they saw the lessons, they learned the lessons already, and came ready to perform.
Yeah, and each task requires a little bit of different competencies. There's some of them have some recognition tasks that have to be done, like the docking challenge. Some of them have where you have to follow a path and avoid things, and then the opposite of that, some require some station keeping and holding in one place. And so to be consistent across all those different capabilities is pretty rare, in a competition like this. So you can often do well by just being really, really good at one thing, but to be good in everything is pretty unusual.
I agree. This task that we like to have fun. This was the theme of this was a day at the carnival. That's why I'm sort of wearing something funny today, because I'm the ringleader. We see teams that try to design well for all tasks, or pick a few tasks and design well for that, and maybe not do so great at other tasks. For example, snack run is a task that I love to keep because it kind of puts a monkey wrench in the plan to do just holonomic drive and just strafe all the time to get perfect motion. When you do a holonomic drive like that, you tend to lose efficiency and can't do fast maneuvers very well or go fast at all. So by keeping a task like that, while also doing fine manipulation tasks, really requires some system engineering thought processes, some decision making, some optimization. That's kind of the stuff we're looking for. And I agree, some of this also takes a lot of nautical type situations at hand. We'd like to see the talent grow and learn to tackle problems like station keeping, or when you have external forces applied to you while station keeping, or navigating channels, or other situations that real autonomous vessels will be facing out in the environment that they're going to be operating in.
So we've been doing this, for a few years now, and some of the tasks have been more or less consistent over the years, right? The navigation lane, the obstacle avoidance, the docking, and then others are pretty new for this year. So I wonder if you can give us a little peek behind the curtain from the design process, Bill, and just tell us a little about the tasks that are a bit different this year. What was the thought process behind it, and how did you calibrate the difficulty in a way that you thought that the teams would be able to find them approachable, but not too easy, not too hard?
Well, like most innovations in tech, it sort of started in my garage. But no, we had actually prototyped, me and a few colleagues prototyped some of the newer tasks. We ran trials, not with a robot, but with just human-operated ability. And we did an iteration based on how easy it was for a human to do it. And once we felt pretty confident that a human could do it, okay, now let's see how an autonomous vessel can do it. We did make some changes in site. Some of the stuff was built on site. We did have our own challenges. I think a lot of students don't realize that executing the competition is almost as challenging as being in the competition. For example, water blast, the tape I used to seal the pipe worked great in all my testing until I got here in the heat of the sun. The tape did not hold up to the extreme temperatures that I didn't have when I was testing this back home. So we also had some lessons learned coming on site for things that we didn't account for. But we kind of sat down with a theme. We kind of thought what would be fun visually that matched the theme, and one of them was skee ball. We always like to have some sort of manipulation task where they have to throw or project an item into a task. So skee ball made sense. And then like you said, for one of the behaviors earlier, I've always wanted to do a station keeping task, but it's not very fun to watch, and it's also hard to judge because it'd be hard to define an area and just tell a team to stay there. So when I came up with water blast, I went, oh, this is perfect, because it's a task that requires station keeping, but you'll have your own internal influences applied when you start shooting water. So now you've got to learn to develop a control system that will hold you still before you shoot the water, and then hold you still while you're shooting the water or trying to aim it into the task. So for me, that was a great task to come up with. I consider it the hardest task because I think those are hard challenges to overcome. But I was really happy to see some teams were actually able to lift that ball up. Not many, but some teams were. And I am glad I was able to come up with something that is a station keeping themed task that we can easily judge and see how well they do.
Yeah, and the other aspect to that is that we always try to have some sort of real-world analog to a lot of these tasks. Everything is something we really would want an unmanned surface vehicle to be able to go out and do in the real world. And when I saw that station keeping water blast task, I instantly thought of that big news thing from just a couple of months ago where there was a container ship on fire out in the ocean. It was big news because it was full of luxury vehicles, right? Yeah, I don't know if you remember that. And then there were photos of this burning ship, and there were all these tugboats that went out there to fight the fire and squirt water on it and just try and keep the whole thing from sinking. And so that just immediately made me think of that and how much it would be safer and also more efficacious to be able to send a bunch of unmanned firefighting vessels out to deal with that kind of situation.
Who's talking? Okay, all right, so we're moving on. I agree, that's definitely a real analog, but I'm going to have to stop because Embry-Riddle is now up at the first gate and ready to start, so I'm going to pass on the microphone. River.
All right, so Embry-Riddle Aeronautical University is up, and River is here to join me on the commentary desk. We're going to have to share a mic here, unfortunately, River, but welcome. Thanks for joining us.
Thank you. It's a privilege to be here.
So can you tell me a little bit about the boat that you have this year? Your university is renowned in these set of competitions. They take part in all the RoboNation competitions. It's always a pleasure to see you guys here. And the boat looks a little similar to the last time I saw it, but maybe can you talk us through a little bit about what's new and what the team makeup is like this year?
Yes, sir. So the majority of our hull is reused from the 2018 competition, and we have added wood parts on the side. Those are new. A lot of internals have changed. So our team completely redesigned the electrical system. We tried to maximize the external and internal space. We've moved our antenna, and we've also made adaptations to our light tower.
And the team this year, they seem to be a kind of a younger team than usual. And so is everyone who worked on the boat here, or did some of you have to sort of take over at the last minute? What's the vibe like on the team?
So the vibe of our team is very close-knit. I know all of the other members on our team through the Intelligent Ground Vehicles competition, and we competed in 2 different sections of it. And that's what led 2 of us to this competition. Really, we've only been involved for 2 weeks, while the other 2 members have been on this for a semester each. And yeah, I'm just really proud of how we've been able to pull everything together.
Yeah, it's super commendable to have a team that half the team has joined kind of at the last minute, but fortunately has a lot of skills developed in the other competitions to be able to just pick up the ball and start running with it. What's the week been like? And we can stop talking about this once as soon as the boat takes a run. I'm seeing it sort of lining up here first, but just while we're waiting for it, how's the week gone? Has it all been smooth sailing?
Well, our days are long. We're working when we get off of site, sleep when we're dead, I guess. So really, we're just trying to get all of our systems to work together. I don't know what to say. Yeah.
Well, would you say that integration has been the biggest challenge this week? Have the individual subsystems kind of been stuff that you've already had working, and it's just been a matter of trying to bolt them together and getting them to work together, or have there been other major challenges on site this week?
So we've had a few obstacles that we've had to overcome, especially in our software, just working out the nuances to get our vehicle to essentially our main priority was to get our path planning to work, which uses our Velodyne data, and everything's compiled into ROS, so that's been helpful. Our ROS has been working, our embed has been working well. There was definitely a lot of stuff that we had to work out, such as we were getting like an overflow of data, fixed that. Yeah, just a lot of minor things overall.
Yeah, if I recall correctly, Embry-Riddle was one of the first teams, if not the first team in this competition to come with a LiDAR, and that was sort of a bit of a game changer a few years ago. And so has that aspect in terms of getting a depth cloud from the LiDAR, is that all the sensing side, has that been performing as planned this week, and it's been mainly a data analysis problem this week, or have there been any problems on the sensing side?
I would say more so on the sensing side. We've noticed a bit of tearing in some of the data when we move. Getting our orientation was an obstacle that we faced over last night, and we've got it, I'd say, about 90% there. But when the amount of error that we have is 6 feet between buoys or so, that can make all the difference.
Yeah, is there anything that has been anomalous about this course for you compared to where you've been able to practice before coming to competition? Because sometimes for some teams, they'll get to a site and their magnetometer will be weird, for example, or something like that. Something's different about this site compared to where they've practiced. Is there anything that you've sort of noticed in that area?
Yes, so the place where we practice is a small pond on campus, and we've brought buoys into it. However, it's only about 2 feet or so deep. The conditions here are much different. There's been a consistent current that has changed directions throughout the week. That changes how we prepare our path planning. So each time we run the course, there's some dynamic change that we're going to implement when we're trying iterations.
Yeah, one thing that's just sort of noticeable to me about this site compared to the last 2 RoboBoat sites is the watercolor, and I just wonder if that's something. If anyone's using color information to for example, disambiguate LiDAR results, and whether that the sort of turbidity and the kinds of algae that affect the watercolor, whether that's anything that's affected you.
This has not been an obstacle that we've had to work with. We're not really focused on color data. We do look at intensity data, though.
So the really bright sunshine out here, has that been an issue?
So what we did is we have a small section of the data that is actually coming in. We're sort of cropping the screen, if you will. So we're only focused on a particular area that we can see with our Velodyne.
Yeah, so another question about that is, I was out there on a kayak a little bit earlier, and while the breeze on shore is nice and cooling, when you're out in the kayak, it's moving you around, and there's a visible choppiness that's even more so when you're down low to the water. You can see that, and so the boat very low to the water. Is that choppiness on the surface from the wind? Is that anything that gives you spurious LiDAR results, for example?
So the choppiness of the water is something that we kind of accounted for a few years back prior to all of us being on the team with the design of the hull. We have a low center of buoyancy on the vehicle, so it helps stay on course while there may be, changes near the surface of the water. On top of that, I don't know, yeah.
And for all the students on the team this year, this year, after 2 years of no in-person competitions, has anyone been to competitions before this year? Is this brand new for everyone on the team?
I can answer for myself and one other member of our team. So half of our team. So we've been to one other competition that was a few weeks ago, and we had minimal time to prepare for that, where the other two members of our team have been to other competitions and are involved. They've been involved with RARE, which is our robotics association at Embry-Riddle, for some time now.
So enough time that they were able to attend other things prior to the pandemic shutdown?
Yes, we do have a great skill set on our team. We have diversity among our members and our specialities, despite being all the same major, mechanical engineering, and we're all specializing in robotics.
So I couldn't tell then if that was the start of an autonomous run or not. Do you know, are we starting runs now, or is it doing a little bit of practice and data collection?
Yes, we are currently making a run now.
So far the tasks that you've qualified on are this initial task, the mandatory navigation channel task, the obstacle course, and then I believe the speed challenge, the gathering snacks, were the 3 qualifying tasks. What's the game plan for this first final slot? Are you going to just try for those again, or trying anything new?
Our game plan is to focus on the final qualification aspects, and to my knowledge, we are only our last run counts. So we will use that information and try and come up with a game plan that will lead us to success.
All right, but this is this is not the end of this competition. This is the first of a number of final slots that are available to teams that have qualified, and there's a whole nother day of RoboBoat tomorrow, weather permitting. So reach goals. Besides getting some points on the board now in finals, do you feel like there's still a little bit of work that can be done to try and attempt to score points on some of the elements that you haven't scored points on yet?
I would say that we know the limitations of our vehicle, and we have a list of priorities that we think that we're likely to accomplish and score well in. So we're prioritizing the tasks that we have determined are most likely to succeed, and time is a huge factor out here, as well as our batteries, recharging stuff. You have to, with such a small team, we have to have somebody watching our batteries when they're charging, and we have 3-4 people working out here doing different tasks at the same time. It's difficult to manage our time as efficiently as possible when there's so many things going on.
Great segue. What's been your personal role on the team so far? And feel free to include what you personally worked on in IGVC too.
So personally, I'm kind of everywhere, from working on hardware stuff. I came up with a way to mount our antenna on the boat when it used to be on the front, and just to maximize our space and make sure that all of our internals were going to be waterproofed. We ended up moving that, so a few runs to Home Depot, that's what does the trick, and fashioned something to put on there. I don't have much experience in C++. However, myself and another member that was on our self-drive team with me, we have some Python experience, and we're able to incorporate some of that knowledge and transfer that to C++. However, it's limited. We do have Anna. She's our primary software person, and she's a wizard on there. Dominic has really come through. He's our team lead, and he's been working with our electrical system, getting that to be pristine. And so far, we've only had real issues with our servo. So that's what spins our motors, not what sort of powers them, but what orients them. And we have two of those mounted in a straight line, longitudinally on our vehicle. We troubleshooted a few different ways that we could orient them to turn and maneuver. However, we've decided on just using one at this point in time.
Yeah, one other thing, that's it's always a problem in Florida. I guess to some extent, being natives, you might be used to it, but it's just so hot here. It's like it's hard to express to anyone watching at home just how hot it is out in the sun here. And so I'm wondering if you've encountered any thermal issues on the boat. I remember this boat used to have a liquid cooling loop, utilizing some of the water from the lake that it's on. So I'm wondering, is that still there? And has there been any issues there with respect to thermal management?
Cool. So yes, that's correct. We did used to have a water cooling system. However, this year we incorporated some slots on the back that are similar to how a building would just have open vents on the sides where it's waterproof from rain. And our boat functions the same way. We have ventilation on the back that keeps the internals cool. And what you were saying, along with the heat, I'm not originally from Florida, but I think keeping our morale up, staying positive. We're a tight-knit team. I'm really proud of how everybody has functioned, and getting up every day super early after going to bed really late. It's just awesome to see everybody out here working their hardest and just giving it our all. And it's all fun too. So really, this is primarily a learning experience for all of us, and it's just I'm grateful to be out here and learn as much as possible. It's a lot of information to get in the 3 weeks that I've been involved, but I can tell you, you learn more doing stuff than you do just maybe sitting at a desk. So yeah, I'm really proud of the morale despite the heat out here, and we have not had any internal overheating issues. We've been monitoring our systems fairly regularly. We try to minimize how often we are using the motors and how quickly we are when we are in our RC mode, controlling it via remote control, so that we can conserve battery power, minimize heat for when we're trying to run it autonomously.
Yeah, in that case, I apologize to the team that I told to go and see you guys and take a look at your water cooling system. But on that note, it is so great to be out here again, especially after 2 years of everyone being remote. To be here in person is just so fantastic. And in particular, your team has had a reputation. I don't know if you know, but for many years, the Embry-Riddle team has had a very strong reputation for being incredibly generous and open to other teams, helping them out, sharing the knowledge and techniques. And I just wonder, what's it been like for you being here in person this year, meeting the other teams? Have you had the opportunity to do that sort of peer mentorship that your team has been renowned for?
First off, I would like to say that we've had incredible mentorship from our faculty member, Dr. Coyle. He's an incredible resource to us, and he's a really great source of knowledge. And when it comes to working with the other teams here, it's a competition, but at the same time, we want to see everybody succeed, and I think that's the mindset that everybody has here. We've gotten some parts from other teams. They've gotten some parts from us, and we're just willing to work with everybody so that everyone can achieve, the best result possible. I think, we all want to see success, and whatever you need to do that, we're open to it. So.
Yeah, in many ways, I think these competitions are like a conference. The stuff that you learn from seeing other people and talking to them and looking at their approaches and so on is at least as valuable as all the preparation you put in ahead of time. And then also, it has to be emphasized what a challenge everything on this course is. It's so difficult, and so in a way, all the teams are competing against Bill and his challenges as much as they're competing against each other.
Yeah. Along with the theme of this week, it is kind of a circus out here, I suppose. Yeah, I think that just how dynamic this course is with the outdoor factors, wind and this current that has been pushing against us this entire time. We really, I don't know, we just need to have it keeps us on our toes. So we're constantly thinking of possible ways to combat this course and achieve the best result possible.
Yeah, just as we're saying that right now, the wind has really picked up. It's blowing straight from the water to us here on the shore, so pushing the boat directly away from where it's about to try and go through the navigation channel. And so that's just a question that I have is, how, if it does at all, does the boat assess the severity of the wind, and any associated currents? Do you do any sort of attempt to characterize the instantaneous environmental conditions, or does your path planner just say, here's where I want to go, and I'm just going to go as hard as I need to go there?
I think you hit it. You hit the nail on the head with the latter option. Our path planner is in RViz, and we basically just plot a line in there and try and get our boat to. It turns our servos and powers our motors to get onto that path within a margin of error, and it detects the buoys. It can see essentially everything that we can see sitting here right now.
Yeah, I was thinking about this a lot when I was out on the kayak and I was being pushed around by the wind and drifting through things and so on, and I was just sort of thinking about navigating the obstacle course, especially if you can see a long way, right? If you can see most of that channel, you could plot these waypoints between each pair of channel buoys in the obstacle course, and you could plot the position of the yellow obstacles and so on. But then, how do you decide when you've passed one of those? If you chained a lot of waypoints together, then you have to decide when you're past one or not. Or if you're just going to the most distant waypoint, that could potentially take you out of the curved channel. So, sort of, what's the algorithm behind that? And it would probably be more fun if we talked about this while it was doing it. But for the moment, anyway, what's the general algorithm for doing something like the obstacle course, where you kind of want to go between all the things, but you also don't want to sort of stop and go back?
So I'd say this comes into question, especially at the start. For us, once it's on our path, it essentially keeps to that, despite some sort of error. We're not completely sure what it is at the moment. It's probably something in our do you know what direction this is? Cardinal?
No, I don't.
Oh, okay. Basically, when we're trying to complete the task that we were just doing, the obstacle avoidance, the way that that's pointing forward, and we turn our vehicle, the points sort of smear back at us, and we're trying to fix that in our code currently, and we've been sort of correcting for that in our path planning. And when we start, we want to start a little bit farther away from our initial sort of waypoint, and our boat will go to that, and it stays along with that. I have limited experience in ROS and the entire environment that we're working with. Again, I've only been in this for a few weeks now, so my expertise is limited.
Yeah, for sure. I mean, part of the context behind that question is sort of, for the people who are watching who don't know a lot about robots, because some of the things that are obvious to a person about the challenges are not obvious to the robot, right? So in the past, with the obstacle course challenges, we've definitely had situations where the robot knows where it starts and it knows where the end is, and it decides, well, the best way to avoid those obstacles is not to go in there at all, right? I'm just going to go around the outside, but that's not what's going to score the points. So you sort of have to think carefully about, well, how do I set the algorithm up to force it to go through the obstacle course and traverse that, when in many ways the most logical option is to, for avoidance, is not to go there at all. So, the exact algorithm, just from a high level about how that works, once you start to think about it, it's not necessarily easy.
That's absolutely correct. Our boat features 4 degrees of freedom compared to most a typical speedboat that you might think of, because we have these 2 motors on it, and the way that we were using them, things behaved quite differently than they do now, and that has been honestly one of the biggest things that we've had to overcome, because we used to use 2 to steer. We were trying to use the one in the center as a source of thrust, while the rear was going to be stationary, fixed sideways, and we would use that to power either forward or backwards to push the rear of the vehicle in either direction and spin about the center, sort of. That proved a bit difficult to incorporate in our code, so we went with the simplest solution possible, gave it just power to our rear servo when we're in autonomous mode. We do use both when we are in RC mode, but this is about autonomy here, so yeah.
Yeah, it's that's another good example too. Is just sort of the drivability of the robot. The human has a very good adaptive controller. They get a feel pretty quickly for how things move out there, and then you can learn how to drive the boat. But to program a controller to be able to keep everything on track, especially when the wind might be in a consistent direction, but depending on where the boat is facing, the yaw moment that wind produces can be quite different. So that even a consistent wind in one direction can be trying to spin the boat at some times and not spin the boat at other times, depending on which way it's facing. So without some sensor that tells you the wind direction, that can be really tough to deal with.
Who's your ramp person? Beg your pardon? Who's your ramp person? Is one of you the ramp person?
Oh, yeah.
Oh, you are. Okay. Sorry, guys.
Okay, it's all good. Sorry, could you repeat that?
Well, I was just observing that you can learn to drive the boat and get a feel for how it responds, like pretty quickly as a human, with all of the adaptability that a human brain has. But programming the robot to do that, especially taking into account the environmental conditions and the fact that the wind doesn't just push the robot translationally in a direction. It also, depending on which way the boat is facing, can spin it and impart a yaw moment. So that can be a very complex control aspect, just to keep it facing in the correct direction.
So when we are using our path planner, what it does is it changes our orientation first and then moves accordingly, rather than sort of doing both at the same time. And it's proved to work pretty well despite wind, and I think our external physical design has really helped with that, minimizing really large objects that could catch wind and just minimize our boat getting pushed around from that.
Have you encountered any latency aspects with doing it in that sort of two-part method? And what I mean is, I could imagine a situation where you get oriented, in the correct way, and then you prepare to drive forward. But in the sort of context switching time, now you've drifted laterally, and so the orientation needs to change again, and so you sort of never get to, by doing it in two modes, do you have some sort of potential issues where you're constantly in the first mode because the drift, in a strong wind, the drift is constant.
Do you mean switching between our orientation and driving? Oh, I see. No, I don't think that it's caused us any difficulties compared to how our ground vehicles worked. We just plotted points for that, and it works a bit differently with this. We're plotting lines, so.
Yeah, so I'm just curious because the difference with the ground vehicle, it's sort of like, you could imagine driving on an ice rink, right? So, like normally you drive a vehicle and if you stop driving, it doesn't go anywhere. But if you were on like a really, really low friction surface and the wind was blowing, then you could imagine sliding all over the place. And that's sort of, I don't know, it's just sort of analogous to that situation, or at least it sort of illustrates how much more complex the on-water navigation behavior is, seemingly to the ground vehicle, where in most cases it's not moving if you stop moving deliberately.
Yeah, so that drift has been primarily an issue when we're starting again. Luckily, switching from our RC mode to our autonomous mode is very streamlined. We have a good antenna, we have a good system, and we're broadcasting, I believe, at 5 hertz, 5.7. So we're not on the same sort of bandwidth as a majority of the other teams here, so we don't have to worry about a lot of interference issues. Yeah.
As we start to get the next team in the water here, I gave the last team an opportunity if you have any sponsors you wanted to thank, since this is going out on the web. So is there anyone besides Dr. Coyle that you want to give a shout out to?
I mean, yeah, big shout out to Dr. Coyle. He's a huge resource, huge help, and we couldn't do it without him. So there's that. Big shout out to RARE, our robotics association at Embry-Riddle, and thank you to VectorNav.
Definitely thank you to VectorNav. Actually, it was, going back to Embry-Riddle, always helping out other people at the competition. It was, I have a RoboSub team, and your team turned us on to VectorNav and said that they sponsored us. Give them a call. So we called them, and they sponsored us too. So definitely thank you to VectorNav. We love them. Thank you very much, River, for joining us. Good, well done out there, and hopefully a couple more final slots, and maybe we'll talk again later today or tomorrow.
Thank you.
All right, so Embry-Riddle coming out of the water now, and going in the water is our team that's come here all the way from Israel, Tel Aviv, and hopefully we'll have a representative from that team coming up and join us in a minute. I'm not sure exactly where we are on the clock right now. Okay. And Tel Aviv So yeah, Tel Aviv University is getting in the water. Their 5-minute dock time just started, and joining me here up on the commentary desk is Noi. Welcome, Noi.
Hi, thank you. Nice to meet you.
So what we're going to do, we've had some technical difficulties. We're just going to share this mic, so I'll just hand it to you when you want to say something, and we'll swap back and forth. But I was so excited when I saw you guys here in the competition, because this is the first time, as far as I know, that we've had an Israeli team in the competition. It's such a long way to come. So can you tell us how you found out about it? What caused you to form a team and come all this way?
Well, actually, last year we participated through Zoom. So we had a remote test. So it's really different from this. And the team was conducted last year. This is a part of our final project in our engineering degree. So most of us are graduating this year. And this competition, instead of doing a project in a lab or something like that, we chose to be here and to take a part in a team of different engineering degrees. I mean, we're all electrical and mechanical engineering, and that's how this happened.
Yeah, that was my follow-up question, was in terms of a final project. I think in the US they call it a capstone project. Is that the final project for these different departments, or is it only considered to be the final project for for mechanical engineering or for whichever? But does it count for every department?
Well, as I said, we are both electrical and mechanical engineers. So for these two groups, this is a final project.
Yeah, so the university recognizes it for all of you. Yeah, cool. And so, there's a number of robotics competitions you could have participated in. So what was it about RoboBoat and the maritime surface robotics that attracted you to form this team?
First of all, I think that the fact that it's all in the ocean is a major challenge, and that what makes this competition interesting and challenging. The guy that built the team last year, he was from the Israeli Navy, and actually a lot of our group members were a part of the Israeli Navy. So some of them wanted to join here because they had the knowledge of boats, of navigating in the ocean. So that's what made some of us come here and choose this competition over something that's ground robotics.
And so, what has so far the experience been like for you? How much practice were you able to have before getting here, and then how has everything felt once you're here on the course, trying to get everything working?
It has been some challenging times. We worked on this project for a few months, since about March, and it was very difficult from the start of building the body of the boat. We had a boat last year. Some of it worked, some of it didn't. And we had a lot of issues with even just communicating with the people that built the boat last year. And transferring the data, transferring the code and everything. And then we had to build this boat and make it work. We had some testing in a much smaller lake in Tel Aviv. We had a lot of fails where we drove to this lake and got everything and pretty much nothing worked. And I'm happy to say that when we got closer to the competition in the following weeks, things started to shift and started to work. And even here in Florida, we made major progress in the autonomous mode.
Yeah, what was it like getting everything here? You're boat looks really great. It's got that nice hull and everything like that, and seems like it all made it intact. So, what was it like to pack everything up and ship it and just try and make sure everything got here undamaged?
This had been a nightmare. I mean, not only that all of us had to take a 13-hour flight and then drive 4 hours, we had to do everything with a huge boat and a lot of stuff. I mean, computers, screens, cords, everything basically. So this took a lot of time and effort, even to think about how to pack this boat. Our mechanical engineers were responsible to purchase and plan and design the packaging for the boat. So even like the dimensions, what would fit in a car, what would fit in an airplane that'd be all right and not too expensive, and also that wouldn't damage the boat. So we took the body, but we had to take all of the electricity and all of the computers out. So when we got here to Florida, we had the effort and a lot of time was put into building everything back together. So wiring and cords and turning back on the computers to see that everything communicates. So this was, I think, one of our biggest efforts, and what makes it more difficult for us than the other teams.
Yeah, absolutely. It's kind of like rebuilding the boat again, and there's the risk that something's going to get broken, something's going to get lost. Did everything come with you on the plane, or did you ship anything separately?
At the beginning, we planned to ship everything because it was a very big hassle to take everything with us. But we had to work on the boat until the last minute. I mean, even the day of our flight, we worked on it. So we couldn't really ship anything and take the risk of things not coming. So everything was put in the airplane. We took an El Al flight, which is an Israeli company. So they all knew and recognized us and acknowledged the boat and everything. So a lot of paperwork was done to make this happen.
Yeah, that's really nice to have some sort of connection with the airline so that they know that they're shipping something important and unusual and not just another suitcase, right? I had a chance to have a couple of conversations with one of your mechanical engineers, very enthusiastic guy, as he was doing some prototyping of the water jet device for the squirting, the water blast challenge. So it seems like there was still a lot of sort of prototyping and tweaking going on here at the site.
Definitely. For electricity, our motors didn't really work in the beginning of the competition. We had to tweak the angles, and our whole control system had issues, and the coding had issues, and everything is in the making. Even right now, we're writing more code to pass more challenges. We have everything, all of the sensors here and all of the computers here, but a lot of the coding can be fixed and tweaked. For example, if we see, we didn't really plan coming here to pass the docking challenge, but then we understood. We saw our sensors recording, and we saw our LiDAR really targets and sees the docking part perfectly. So we understood that the code for this challenge can be written in a day. So we did it, and then it's all in the making. So it's a work in progress even right now.
Yeah, I think that's something people really need to be aware of, is just how much the work continues once you're out here. And how much new work gets done as you get to assess the differences from what you're used to in practice, and the way that the elements work out here. So I have a question about that, which is as you write new code to deal with these challenges, the process for that you're able to come out on the course and practice and collect data, and you're also able to test in the hotel pool. So do you capture a lot of data out on the course here and then sort of crunch that and design your software based on the stuff you've captured out on the course, or do you sort of do a more real-time thing where you're in the pool and you're capturing new data there? Like, sort of, is it more you gather stuff during the day and then you work on it at night, or do you gather more stuff at night and sort of do it in real time?
I'd say both. In the first days we've been here, we took a lot of recordings of to see how our sensors target the buoys and the docking and everything, so we can see what's need to be tweaked in the code. For example, we have both a camera and a LiDAR, so we see some of the challenges we can go through with our camera and some with our LiDAR, but that's what we used for the recording of the path. But then we did a lot of testing in the pool to see our motors. So we took the buoys and put them in front of the motor to see how the camera targets them and to see if they move. So both. We didn't have a lot of sleep this week, but it's fun. It's a lot of fun.
Yeah, I'm also curious with that, for the perspective of a team that's here in person for the first time. What's the vibe felt like to you with the other teams and so on? Have you had a chance to talk to the other teams and do a little cross-pollination of ideas and evaluate some other approaches, maybe help each other out and stuff? What's it been like being here and meeting the other teams for the first time?
For me, I think it's one of my favorite things in this competition for a few reasons. First of all, they help us a lot. I mean, we had to take so much stuff in here, and we used the help of other teams. We asked for help if they can borrow us screens and keyboards and mouses. And people have been offering us to give us stuff and cords, and it makes a huge difference, not only to actually get the stuff we need, but just the vibe in here is amazing. And also knowledge sharing is very important here. We had issues with the electricity, so someone from another college came and helped us. And then, for example, I was responsible for the sensors we have, so the GPS and the IMU, and to set up everything together. And it's interesting to see other boats, how they executed this mission of navigating through the course. So knowledge sharing is amazing, and then you can share code ideas, and you can share technical issues. It helps us a lot.
So your personal responsibility, you said, for a lot of the sensors, IMU and so on. So tell me a little bit more about what parts of the system you personally worked on and what you developed.
Well, I was responsible for mostly the sensors in the boat. We have other team members that aren't here in the US that didn't come, so we all had to take their responsibility also. And honestly, we got a responsibility in the beginning, but then you get to a point where everyone does what they need and share knowledge. I was responsible to set up the accuracy for the GPS and the IMU, and then fuse them both together inside a Kalman filter. So we use a GPS with RTK, and we get a pretty good accuracy. In Israel, our testing was about 20 centimeters, so that's pretty good, and that's definitely sufficient in here in this course. We have, for the GPS, we use both a base and a rover, and they communicate together and fixes the accuracy. And we use U-blocks for that. And then for the IMU, We're using a 6-axis IMU, a very cheap one. That haven't been working that well. And that basically gives us the yaw, so the heading of the boat. And we fuse the data together inside a Kalman filter, an EKF one, to get a small covariance. So we get the location of the boat and fix it each time.
Did anything behave differently once you got here versus in your testing in Israel? And would you say that's a priority to maybe upgrade the IMU, like based on what you've learned out here?
Yes. The GPS was okay. I mean, it was all right in here. Actually, honestly, it was maybe better than in Israel because you get so many satellites in here and you get great reception. But the IMU wasn't calibrated. So the calibration was done in Israel, obviously. And it was, there's a lot of effort in calibrating an IMU. Yeah, tension. Yeah, me too. Opa! This is the responsibility of our cameras. Wow. Okay. Yeah, sorry. So our IMU, we had to calibrate it again because gravity here is different and altitude is different. So we had to make this whole effort once again when we got here.
So what we just saw there was what looked like a successful traversal of the navigation channel, and then an entry into the obstacle course. Looked to me like it went through the first set of gates in the obstacle course. So, given that in a run, it's the last run that counts. I heard a big cheer go up here. Do you think you're going to keep that one or try again?
We're definitely going to try again. I mean, this is just to see how the boat acts, but we have more code to implement and more testing to do in the pool. Definitely we're going to keep going. We're here to get the best results, so we're not satisfied with this. We got even better results earlier today.
I was very impressed by what I saw there because a common approach for teams is to basically just drive in a straight line through the navigation channel and not really use the buoys themselves as a reference. So a common approach is to just line it up, hit go, drive at a certain speed for a certain time, and then assume that you're through. But we saw just then there was a lot of wind, the boat got pushed out of the channel, and it reacted and turned around and went back through the channel. So what was happening under the hood there to make it do that? Because a lot of times the algorithms people run on that channel wouldn't have been able to do that.
Yes, that's, I think, one of the major things we're most proud of is our camera and the targeting for the buoys. So we use an algorithm to educate it and then to detect the buoys. So basically, it has a pretty good accuracy. And what it does, our algorithm, our main focus is to move through the first and second challenges in pretty much the same way. So when the camera targets a buoy, or red or a green one, it fixes it. So we saw, and the first time we went to the lake, we saw there is a major drift. So we couldn't really pass it in a straight line. We kept drifting, and it just didn't work. So we used our camera to detect a red or a green, and then we fix it with an angle.
In that first part of the course, you have the tallest buoys transitioning to the smallest ones. So are there any challenges associated with dealing with these big tall ones in terms of kind of working out exactly where they are? Because where they are at the bottom versus the top, depending on the angle that the boat sees, which is very down low, very close to the water compared to our viewpoint, are there any perception challenges there, just sort of figuring out exactly where everything is when some things are tall and some things are short?
Honestly, this hasn't been because of the algorithm we used. We can detect in a pretty good accuracy both obstacles. So sometimes we miss the red ones, maybe because of light, and also the pictures we used to train the network of the tall buoys were for the red ones. They are more like the green ones. I mean, the red ones here are more tapered, and sometimes our camera misses them. And then for the balls, we usually miss the yellow ones because we didn't train the network with yellow balls. So that's about it, yeah. These are our challenges with training the network for these obstacles. And then we took pictures of the obstacles so we can train the network better next year.
Yeah, how much data is being collected by the boat when it's out there on the course? Do you sort of save everything, all the video, all of the the perceptual sensor results, or do you sort of prune that? How much do you save?
We try to save everything, but we have some issues with communication and also just with storage. But basically, you have a script that's running whenever we run the boat that captures the data. So both we use ROS for the environment. So just record the data of all of the relevant sensors that we can use for to then code the navigation, and also we just create text of the topics. So we do ROS topic echo to the text data, so we can see, for example, the LiDAR to see the arrays. So we can then parse the array and create a code for that.
And labeling all that image data for training, it's like that's a very manual task, right? So who takes care of all that on the team, and how do you motivate them to go through and label thousands of images or whatever?
We take rounds, but basically because of the script is automatic, we use a timestamp. So then we can label and say, okay, we remember that yesterday we had a good challenge where we went through the obstacles, and then we saw the docking station and everything. So we use both memory and we use just timestamps, and then we sometimes use just names. For example, the obstacle of blah blah blah. That's about it. And then we're not such a large team, so we just ask basically.
Everyone helps out, order a bunch of pizzas, and no one leaves until all these images are labeled.
Yes, definitely. As I've said before, we didn't sleep that much this week because we came here to participate and not sleep. We have other times for that. So everyone takes the effort, and we're all staying in the same hotel, and just every evening we go to the meeting room, we reserve it, we see all the other team members and then the judges, and we're just ordering pizza or other food and just code and fix everything in the meeting room. And then we go to the pool and test it.
Yeah, I wonder where the robotics industry would be without pizza and burritos. They've fueled many a robotics project. So it looks like the boat is being rescued now by a kayak. I think we're retrieving it and coming back in for the end of the run. So thank you very much for joining me. Is there any of your sponsors or people who've supported the team over the past year that you'd like to give a thank to out on the air?
Firstly, the university for supporting us to come here. And then we have some major sponsors that helped us. For example, Innoviz that donated us the LiDAR, which is amazing. And then we have Raphael, which donated us a lot of money and also a mentorship. So yeah.
Yeah, I mean, there's such a big tech industry in Israel. Has that sort of helped out in getting finding people outside the university that have been willing to take a chance on helping your team out?
Definitely, a lot of companies donated money, and also just people are curious about this competition. For example, we used Facebook groups for robotics, an Israeli community to advise us. So we put up Facebook posts, asked for help or asked for advice, and even for just support, technical support. And it's a very small community. Very, very technological, so a lot of tech people that are curious and want to help.
That's great to hear. Well, thank you very much for coming and joining me and talking me through this. I know it's always a challenge to leave the team and then come and talk when you're really wanting to focus on what the robot does, so I really appreciate it. Thanks a lot. So that was the third of 3 finals runs that we've had for this afternoon. I am not sure if we're doing any more this afternoon okay, so I'm getting the shake of the head. So I think that just about wraps up finals for today, but of course we have a bunch more attempts tomorrow. I think teams are going to have 2 more final slots tomorrow, and then of course there still is qualifying happening out on the course today and then tomorrow morning as well. So we may see some more teams joining us here in this final sequence, RoboBoat 2022. Then there may be updates. Check our website, roboboat.org. And Bill is joining me again, giving me a little update from the technical side.
Thank you, Zaz. We've had one more team qualify while we've been doing finals. So tomorrow's going to be 4 teams, and we're going to start at 9 a.m. 9 a.m. Eastern. 9 a.m. Eastern will be the morning finals round. Now we are looking at a potential weather forecast. So that's kind of why we did finals today. So it's for anything that we're doing tomorrow is definitely caveated with weather permitting. So
can you let us know who the new qualifier is?
Haggerty High School.
Yes.
Yep.
Dogs.
Yep. Exactly. We're very excited. So we'll hope to see everyone back at 9 a.m. tomorrow to see all 4 of the qualifying teams now get on the finals course and show us what they can do.